Alright, greetings. This is the Unit 2 exam review for BC Calculus. Your test is this week, so I'm going to go ahead and work out select problems from that review. Okay, we will make sure you're kind of paying attention to all these bullets up here. You definitely need to know your 6 trig functions, E and ln. Make sure you're paying attention to those questions from your homeworks where you're using your calculator. Especially the one that I had gone over in class with that 1 minus e to the x squared. Okay, you'll probably see something like that on the test as well. So we'll get started. I'm going to go ahead and just work out some of these problems for you. Letter E here, that's going to be using the product rule, but also your derivatives of e. So to take the derivative of this p of x, we'll say p prime of x, okay? And again, we're going to be using the product rule here. So your product rule says first times the derivative of the second plus the second times the derivative of the first. So in this case, it's going to be first times the derivative of the second. Now the second part of this is e raised to the 2x. So the derivative of e to the x is e to the x, right? So in this case, it'll be e to the 2x times the derivative of the exponent. So that's going to be e to the 2x. You kind of just recopy it, and then you multiply that by the derivative of the exponent. So in that case, it's a 2. So there's the first part of the product rule. And then it's plus the second, that's e to the 2x, times the derivative of the first. And that's just going to be 2x. Okay. If this was a free response, that would be your safe stop. If it was a multiple choice, the answer choice would probably be cleaned up and look something more like this. Okay, so that's an example of, again, the product rule and also your derivatives of e to a power. All right, for letter F here, you're going to be using the quotient rule, okay? So with your quotient rule, remember it's low d high minus high d low, all over low squared. So what we mean by that is to find the derivative, q prime of p, okay? We're going to do the low one, so you leave that just as it is. So it's p plus 3 times the derivative of the numerator. Well, the derivative of this numerator is just a 1, so that's pretty easy, okay? Minus high d low. Well, the high one is p minus 3. And the derivative of the low one is 1 again, all over low squared. I put that in an extra bracket, but it's not really needed. And then it'll be low squared. Again, if this is a free response, you can go ahead and stop there. However, if it is a multiple choice, that will probably be cleaned up. So let's see, I think that's going to be p plus 3 minus p plus 3 when you distribute the negative, all over, they probably would leave that just as the quantity squared. And I'll clean that up one more time. Let's see, this p and this p are going to cancel out, and then 3 plus 3 is 6. So it's going to be 6 over p plus 3 quantity squared. So we'd have that. So there's your example of quotient rule. And for letter G here, we have g of x equals 8 cosine of 2x. So for this one, this is going to be using your trig definitions, but also a chain rule. Again, kind of the parentheses with the chain rule, or the parentheses is kind of a clue that you're probably going to have to be using chain rule. And so we're going to have g prime of x. It's just a two-stepper here. So when you take the derivative, right, the derivative of sine is cos. The derivative of cos is a negative sign. So it's going to be negative 8, okay, and it'll be sine of the stuff, okay, but now it's the derivative of that inside, so that's times 2. So if you cleaned it up for the multiple choice, it would probably look something like this. And you're done there. Again, the clue, we used trig here combined with a chain rule. Whenever you're doing chain rule with trig, you kind of take the derivative as if this parenthesis was just a giant x. You just kind of recopy it, right? Then you're like, okay, I kind of had to substitute in an x there, so, oh, what's the derivative of that parentheses? It was a 2. And for the last one in this column here, let's see, we've got, oh, this will be another chain rule, but you have to kind of rewrite it first. So this one has a few lines of work to it. So I'm going to just say that that is equivalent to 6 minus 5x cubed, that raised to the 1/2. Whenever you see the square root, you should be thinking that something is to the 1/2 power, okay? And now I can go ahead and take the derivative. So notice, this is equivalent to this, but now I'm going to take the derivative, so my notation is going to change to f prime. Okay, so the derivative of this is a very classic chain rule, where the other one was kind of chain rule with trig. This is more of a classic chain rule. So we're going to take this, bring it out front, recopy the quote-unquote variable, and this is going to be recopied that quantity, and we have to decrease the power by 1. Then we're going to have to multiply by the derivative of that parenthesis. So we're going to have 1/2 6 minus 5x cubed. It'll be raised to the negative 1/2 power. And the derivative of the inside is a negative 15x squared. Okay? And again, there's a safe stop, and you've done all the calculus. If it was multiple choice, generally they don't leave negative exponents. It's not really mathematically fluent. And they would probably also combine this there. So let's see. We could actually leave that in the denominator. So if I was to simplify this, there are a couple different options, but I would probably simplify it as negative 15x squared, okay, all over, right, this 2's in the denominator, and then this is going to go to the denominator, and then I'm going to take the square root. It goes to the denominator because of the negative 1/2 power, and I'm taking the square root because it was the power over root. The root part was 2. So it would be that, and then the square root of 6 minus 5x cubed. And that would be your final answer there. Okay. I want to see if I wanted to give you any hints for the other sides. I will put the answer key to the others up there. This first one, you're just going to be using power rule. The second one here, I would recommend rewriting this to the negative 1/3 power and bringing it up, and then you can just use power rule. So some people are probably going to say, oh, I have to use quotient rule there. Well, remember, you can always rewrite things, and if you can rewrite them, usually using the power rule is going to be easier. And for part C here, those are your trig derivatives, but remember, one of the properties of derivatives is that you can take derivatives term by term. So I would just take it term by term there and using your trig. And then again here, I wouldn't use the quotient rule on this. I would rewrite these as negative exponents in the numerator and then just use the power rule there. And I'll put that key online. Okay, so moving on to the next page. Let me just make sure I'm still recording. Okay, so on this next page, these questions, you've had them in your homework. There's definitely one like this on the test. It's kind of a tricky way of asking you for the derivative. Here they're using the definition of a limit to ask you for the derivative, okay? So, for example, in this problem, like whenever you see something like this, your first goal should try to be to figure out what your f of x is, okay? So in this problem, and I think the easiest way to do that is to kind of take the first thing and just kind of put a giant X over all the junk. So here, it looks like I have the square root of some junk, so I'm going to say that my original f of x was just square root of x, okay? So here, my original f of x was square root of x, okay? But that's not the end of the story, because now I see this, then I kind of look to the second part. Clearly, this was evaluated at a number. Here, they're plugging in a 3 where I have the x. So this was f of x, and they evaluated it, right, at x equals 3. So that's kind of what I need to know. And again, this is code for asking you for the derivative. So if I have an f of x, and I want to take a derivative and evaluate it at a number, that's not too bad. All I need to do is take the derivative, okay? So my f of x, well, the derivative of square root of x, again, think of that square root of x as x raised to the 1/2 power, Okay, so if you think of it like that, then it's pretty simple to take the derivative. It's just straight power rule. You're going to rewrite that 1/2 out front, x, and then you subtract 1 from the exponent, so it's negative 1/2 power. And you technically could evaluate it right from there, but most of you aren't going to be able to evaluate 3 to the negative 1/2 power, so it's probably going to be easier for you to rewrite it. So again, this is going to be 1 over, okay, this negative exponent indicates I'm going to move it into the denominator, and I'm going to take the square root of it, and also this 2 is already in the denominator, so it'll be 2 over square root of x. And now I'm going to evaluate that at x equals 3. So when I kind of use this x equals 3, so when I evaluate the derivative at 3, I get, sorry, I got to squeeze it in there, 1 over 2 radical 3, and you're done. Okay, probably have time for one more here. All right, let's see. Find the equation of the tangent line to each function at the given point or x value. So give yourself a little bit of room for these. I guess I will do the quotient one. Okay, I guess I'll just do C. So let's see. The first thing you want to do is take the derivative. Okay, again, if you're writing the equation of a tangent line, what should be going through your head? Well, equation of the tangent line means take a derivative, right? And then you're going to plug it in and use the point slope formula. So here, my derivative, y prime, is going to be x squared. Okay? So it's low, d high, minus high, d low. Okay? All over low squared. Don't forget my square. Okay, so you would kind of, you could simplify that out, but since we are given an x value, right, you can go ahead and plug in from there. It doesn't really matter when you plug in. So instead of making a mistake when I simplify it, I'm just going to kind of go ahead and plug in from there. So I'm saying I'm taking the derivative and I'm evaluating it 1. So 1 squared is 1, minus 2 is a negative 1. So I've got a negative 1 times, negative 1 squared is 1 times 3. So that gives me a negative 3 for this piece. Okay. And then it's minus, all right, what do I get when I plug in a negative, I'm sorry, I'm plugging in a negative 1 there. Okay. So when I take negative 1 cubed, it's negative 1 there. When I do this, that's another negative 2, so that'll be a positive, but then I'm negating it. So I'm going to have this over negative 1 squared is 1, minus 2 is negative 1 again, but negative 1 squared is going to be positive 1. So once you kind of plug in, and again, you could have simplified it first. I just chose not to. So I have this negative 5. If you stop there, you're going to get points off because that is just the slope of the tangent line. They asked me to write the equation, so you need to kind of figure out the y value, okay, the original y value, and then use point slope formula. Remember your point slope formula, y minus y1 equals m, parentheses x minus x1, okay. The problem here is that I don't have the y value. To get this original y value, a point on the original line, you have to go back to the original. So when you plug in a negative 1 into the original, that's going to be a negative 1 divided by, so a negative 1 divided by a, let's see, that's going to be positive. Another negative 1 is going to give you a positive 1. So when you go to plug it in for the y value, it's minus, so it's going to be y minus 1. And then your slope was a negative 5. The original x value they gave you was negative 1, so that becomes positive 1. That would be your safe stop right here. But if you continue on to solve it in slope-intercept form, that would be your answer. Okay, going through this next problem, it's going to be a chain rule problem, actually a double chain rule. So I would start by taking the squared and rewriting it outside. Again, those parentheses are a clue that you're going to have to use chain rule. So when you use chain rule, I kind of picture this whole thing as like one big variable. So it's 2 times that variable, you decrease the power. That part's done. Times the derivative of the inside. Well, the derivative of the inside, that's going to be another chain rule. So the derivative of sine is cos. you rewrite the variable, then you take the derivative of that as well. So you can clean that up to give you this, and then you have to go ahead and evaluate the derivative at pi over 2. So I kind of sketched out a little unit circle here. I just needed pi. So the sign over here at pi is 0, and the cosine there is -1, but it doesn't matter because you're multiplying by a 0. So when you evaluate the derivative there, you get 0. Give it a chance to kind of catch up there. And now we also, just like we did in the previous problem, we need to go ahead and figure out the y value. And I'll actually write this one down since it's a trig one. So now we're evaluating the original at pi over 2 in order to get that y1 value that we need. So when we evaluate the original, it's going to be sine squared of, let's see, pi over 2 times 2 is just going to be pi. Okay, well, sine of pi is 0, and 0 squared is still 0, so I get a 0 there. So when you go to plug into point slope formula, it's going to be y minus y1, which is 0, equals m. I found my m up here, right? So that's going to be a 0, parentheses x minus my x1 was pi over 2. And so my answer, once you clean up, is just y equals 0. It's okay to get 0 as an answer. So that's an example of that. Okay, number 4 says, at what value or values of x does the graph have a horizontal tangent line and a vertical tangent line? So remember, a horizontal tangent line, when you see those words, you should be thinking, take a derivative, set it equal to 0. To take the derivative of this, you would have to use quotient rule. Okay, so you're going to take the derivative of that, use quotient rule, and then set that equal to 0. Here you're going to end up with 2 answers, and I will post the key. Vertical tangent line. For this problem, you should start by taking the derivative, and then the derivative of that is going to have a denominator, which makes sense because, again, we're working with this one anyways. So you're going to take the derivative, and then you're going to set the denominator of the derivative equal to 0 and then solve. And that's how you would tackle number 4. And I've already done an example of quotient rule, so I want to kind of do something different. This next one's a good one because this is using implicit differentiation. So for number 5, I'll work through. For the equation given by this, find the derivative of y with respect to x. So anytime you have kind of x's and y's mixed in and then usually a number on the other side, that's kind of a clue that you're going to be using implicit differentiation, also with related rates, but remember related rates is a topic not on this test. So you derive it using regular old power rule, but the trick here is because we're trying to take our derivative with respect to x, anytime you take a derivative where x is not the variable, you need to slap on a dy dx. So here we're just going to have 2x, okay, minus, now in here I'm going to have to use the product rule. So first times the derivative of the second. Well, the derivative of the second is 1, but it's with a y, so I'm going to slap on a dy dx. So first times the derivative of the second plus the second. Now I just make it a y. There's no dy dx there because I didn't take the derivative of y. It was just asking me for the second term. And now times the derivative of the first is going to be 4, so I'm actually going to sneak my 4 in front there. Okay. And don't forget this term here, it's minus 2y. Again, I took the derivative of y, so I need to tack on a dy dx there. Equals, and the derivative of 4, since it's just a constant, is 0. Remember, your goal for these is to then get dy dx by itself. So here you'd have to distribute the negative, okay? And then once you distribute the negative, kind of move the things that do not, the terms that do not have dy dx over to the other side. So you'll end up with negative 4x dy dx stays on this side, right? I'm distributing that negative. And when I distribute this negative, that's going to go there, but those are both going to go to the other side. And so what's left on the left-hand side is this, equals, if I bring this guy over, he's negative. And this would have been a negative 4y, so when I bring him to the other side, he's going to be positive 4y there. From here, you're factoring out a dy dx. So it leaves you with negative 4x minus 2y equals the right-hand side there. And your final answer then, I'll just write it over here, dy dx, our goal is to get that by itself. So it's just going to be negative 2x plus 4y over negative 4x minus 2y. I suppose I could factor out a 2 from there. So if you wanted to keep going, again, if it's short answer, I do not recommend continuing on because you may risk an algebra mistake and get points off. But if it's multiple choice, the answer may have been written like this is your final answer. Okay, very similar, finding the equation of the tangent line. This is going to be taking the derivative with implicit, but then you're going to be plugging in. All right, let's take a look, kind of skipping down. Number 7 is a good one just because it's asking you to take multiple derivatives. So here, if this is your f of x, to find f prime of x, the derivative, this is straight power rule. So it's going to be 4x cubed minus 2x. There's your first derivative, and it was asking me to evaluate that derivative at 2. So to take that derivative and evaluate it at 2, I'm just plugging in 2. 2 cubed is 8. 8 times 4 is 32. And plug in a 2 there, I get minus 4. So my answer there is going to be 28. And now if it's asking you to take the second derivative, okay, that means I'm looking here before I take my derivative. So when I take the derivative, 3 times 4 is going to be 12x squared minus 2. And if I'm evaluating that at 2 as well, I plug in a 2. 2 squared is 4. 4 times. So we are going to get 4 times 12 is 48 minus 2. So my answer there is going to be a 46. Okay. Let's take a look going on to number 8 here. Okay, so this is where you're going to have to use the product rule to first find this. So you're going to have to say first times the derivative of the second, and then you'll actually have to, just write an f prime in there and then evaluate. So I'll kind of leave the answer, but I'll kind of write how to find f prime, or I'm sorry, h prime first. So you would say first times the derivative of the second. Well, what's the derivative of that? I'm just going to write it out like that. Plus the second times the derivative of the first, which is 6x. And then from there, you would kind of go ahead and plug in. And again, I'll put the answer online. K is the interesting one, though, because to figure out the derivative, okay, to figure out the derivative of K with respect to x, you're going to have to use chain rule, okay? So it's going to be the derivative of the outside, so it's really this, of the original there, times the derivative of the inside would be this. So then from there, you can go ahead and plug in there. All right, last page. What do we have here? Okay, so on this last page, you are given the opportunity to use your calculator. Your test will have a calculator section this time, so make sure you're taking advantage of that. If you're asked to find the derivative and you are given an x value, again, you can do that straight on your calculator. Let me just grab a calculator. Okay, so on the calculator, I hope you can see that. Okay, to find the derivative on the calculator, you hit Math. You go down to choice 8, okay, and it should look like this. So then you're taking the derivative with respect to x, and you just type it in. So e raised to the x multiplied by cosine of x, close your parentheses, and here you're evaluating it at 2. So you hit enter, and make sure your calculator is in radian mode. Your calculator is always in radian mode for calculus. So you get your answer there. So once you have that slope of that negative 9.79 number, okay, you would go ahead and plug that in to point slope formula and then go from there. And that's how you would tackle number 9. For number 10, okay, so at what point on the graph of this does the tangent line have a slope of -1? Okay, so when you get a question like this, what I would do is take the derivative, okay, so you take the derivative of this, and I would put that into the y1 on my calculator, okay, so I would take my calculator and go ahead and hit y equals, and the derivative of that would go into your y1, and we want to know when that equals -1. So then go to your y2 and you would type in a -1 into the y2. Use second and then the trace button here, and you're trying to find the intersection. So it's choice 5, and you actually have to hit enter 3 times. It's going to ask you for the first curve, the second curve, but go ahead and just keep hitting enter until it gives you the answer. Your answer there was about 1.269. Once you get that 1.269, remember that's the x value. To get the y value, you're going to have to go back and plug that number into the original. And again, you have your calculator, so just be careful on something like that. Okay, and for number 11, we're trying to estimate the derivative of 5. So notice here that we are given the table, and if it says estimate, that's exactly what you're going to do. See how here 5 would fit between these two? So that means I would say that the derivative at 5 is going to be approximately, well, it's going to be the z of 6 minus z of 4 all over 6 minus 4. Okay, so z of 6 minus z of 4 all over 6 minus 4. And you're just going to grab those numbers straight from there. So it would be this 3.145 minus 2.112 all over 2. And use your calculator for that. And I would get something like 0.5165. So round to 3 decimals for calc. So go ahead and just call that 0.517. And that brings us to the last line. Oh no, the lights just went off in my room. Please hold. Okay, so how would you tackle something like number 12? Parallel lines have the same slope, aka they have the same derivative. So what they're really asking you for in number 12 is to take the derivative of each, okay? And technically you could just grab the slope of this line by solving for it. That's an easy way. Or you can use implicit differentiation. But either way, you should get a slope of 3 for one, and then you can take the derivative of the other, and you're going to set those two equal. So when you take the derivative of this first one here, I got 3 square root of x over 2. So you're going to take that and set it equal to 3. And from there you could just cross multiply and solve for x. And then when you get that x value, simply plug it in. I got 4. So when you get the x value of 4, plug it back in to the original to get the point of intersection there. So my final answer was 4, 8. And again, I'll put that key on line. Okay, hope you have a great day, and good luck on your test.